Hello, everyone. I'm Tracy, and I want to welcome you all to this session. Today, we'll be diving into a real-world look at one of the largest food companies, Kraft Heinz, and how they're transforming manufacturing with AI. In this session, you'll hear directly from the leaders driving this change. They'll take us inside Kraft Heinz's digital core, from their digital twin, delivering real-time recommendations on the plant floor, to how they're scaling AI with Azure Arc and Microsoft Foundry. Get ready for actionable insights and to learn more. And join me in welcoming Oliver, Head of Digital Product Management and Innovation, and Pat, Global Head of Decision Intelligence.
My name is Oliver Genscher. I'm 4.5 years with the company. I'm the head of product management innovation. Before that, I was the head of digital manufacturing. My whole career, I was working in operations. I was building plants, automating plants, and digitizing plants.
And I'm Pat Nestor. I head up a team we call Decision Intelligence. This is our internal data analytics and AI team at Kraft Heinz, supporting centrally to all of our markets and teams globally.
Let's get started. So, Kraft Heinz. I hope your fridges are full of ketchup, Philadelphia cream cheese, Lunchables, and we also hope after the session you will put ketchup on your ketchup. So we're one of the largest CPGs in the world, 26 billion of revenue. We have 36,000 employees working across the world, and we have more than 70 factories globally. What are the things you don't see on the slide? Let me tell you a story. 1869, when John Heinz was going from door to door and was selling horseradish in the clear glass. Why in the clear glass? Because you could see the purity of the horseradish. 1903, James Kraft also went from door to door and was selling cheese. And he has improved the shelf life over time just with the pasteurization process. And 7 years later, he created the beautiful Kraft Heinz ketchup. Why I'm telling you this? Today we have 200 brands. If you multiply this by 25, you will get the number of SKUs we have to manage today. So it's a lot of complexity we have today, day in and day out. Can we still innovate? The answer is yes. We have been awarded as the most innovative companies in 2024 and 2025. We're competing against the Googles and Amazons of the world, and we could show that we can still innovate. Our connected ecosystem. In order to solve end-to-end problems, you need to think end-to-end. What you're going to see here is our value chain from farm to consumer. That's our daily life. That's what we have to manage on a daily basis. You have to plan, you have to order, you have to process, you have to package, you have to forecast the demand, you have to track it, and then you bring it to the retailer, and then you bring it to the consumer. That's the physical path. But what you also don't see, there's also a feedback loop, right? Either you can have great feedback that you love our products, or you're giving us some feedback on where we can improve. That's the information flow. Something needs to improve. I have some material in my jar, and I have certain, the product doesn't taste as it should taste. So all those feedback we're getting across the value chain needs to be managed. And our vision is that we have everything end-to-end connected, supporting us on a daily basis to solve end-to-end problems. What we will focus today is in manufacturing. We have certain use cases to share with you. Our main focus will be the digital twin. We're also going to share with you how Kai is changing the way on how we operate on the shop floor, and also how our cognitive decisions intelligence layer is helping us to take better and faster decisions. We can't fix what we can't measure. Well, it sounds like typical management science, but this is what it is, what we do in operations. Every great strategy starts with a problem statement and opportunities. When you look on the left side from the slide, our digital manufacturing opportunities is we have opportunities in machine performance, which is directly translated into the OEE, which is the overall equipment effectiveness, which is on how well your line is running, and also how good is the quality of the output. Then we have yield. When you envision our lines with processing and packaging, filling, case packing, we're putting raw ingredients into the line, we have an output, but the input doesn't equal the output. So something is happening between the line, which we call yield losses. And of course, utilities. In order to make everything work and manage those KPIs, we have our Kraft Heinz management system, which is a definition of our processes and KPIs on how we can get better every day. In order to be successful, you also need to have the best talent in place to run operations and also transform. When you now move to the right side, our digital vision is very simple. Step number one is we would like to have a paperless operations. We don't want to have paperless operations because it's a fancy term to have no paper and just working with tablets. We're really addressing specific problems because digitizing the information which are on paper today creates a lot of value for us and helps us to understand better our opportunities. In step number two, we're getting recommendations out of the information on what we gather from the shop floor on how we can better run our shifts. Our objective is how can I run the perfect day? How can I run the perfect shift? And how can I run the perfect hour? Because when I have the perfect hour, I have the perfect shift, I have the perfect day. Number three is, you all heard it, predictive and prescriptive solutions. Yes, so when we have the data foundation in place with the visibility and we understand our opportunities, we can use those data, apply certain models, and they can give us a recommendation how we can run better. Today, we're really happy to share with you touchless manufacturing. What does this mean? Step number one is the human is still in a loop and is taking decisions. Step number 2 and 3 is the human is on the loop and is getting recommendations and can still decide on how to run the line. Step number 4 is where the human is out of the loop. A machine is talking to a machine. And we're really fortunate to share with you, after 4.5 years being on this journey, we went through the full transformation cycle in manufacturing. Everything starts with a great infrastructure or data. It's the same when you're building a plant. When you're building a plant, you have to invest most of your time in the infrastructure. It needs to be close to perfect because it impacts safety, quality, output, and also on how you feel working in the plant. Because when the infrastructure is there, you just need to configure inside and you have several options. And the same thing is what we do with data. Today, we're using all those available Microsoft tools which have been presented today to build this foundation, to build the infrastructure, and we're using Microsoft Foundry to use those data to get better insights. So what I'm sharing with you today, which is when you're coming from manufacturing, it's very challenging to get those data out of those machines because those machines speak different protocols. They speak different languages. Today we have more than 50 protocols, and also we are more than 156 years old. So you can imagine that some machines are not even talking to us. So we figured out to get those data to a single source of truth, which basically helped us to better understand our opportunities. Today we have more than 8,000 connected machines. We have 3,000 use cases. And every use case, we're solving every day a new problem, which is helping us to get better every day. And what you see here is the end-to-end connectivity of the full North America network. Our journey. We had a great partner on our side, Microsoft. We started this journey together in 2023, where we identified certain opportunities. We were looking in marketing, we were looking at sales, we were looking at procurement, we were looking at supply chain, we were looking at manufacturing. So every great journey starts with great people and what's the right problem to solve. And Microsoft helped us to identify the right problem, helped us to build the business case, and also identify what it takes to address the problem. We have identified that the digital twin can bring us on the next level. So what does it take to get the human out of the loop? At this point in time, we didn't know what to do. It was a great idea on a slide, signed off by our executives, but we knew it will bring value. So we started with an MVE, a most viable experiment. We didn't know the outcome. We don't know in which direction we want to go. Let's figure it out together. So the industry solutions engineering team from Microsoft helped us to identify these opportunities, run this experiment in Beaver Dam, one of our oldest cream cheese plants in the network, and brought us on the next level. They helped us to test several models and see on how it's behaving when I connect a machine to a machine. Specifically, when I apply certain data models impacting our filler. One of the biggest opportunities in our business is overfill. So this was one of our starting use cases. They brought us to the MVP. So we created them with them a most viable product. We kicked it off also together at the Hannover Messe. And also we got a really prestigious award at Kraft Heinz, which is the Golden Noodle Award. Yeah, somehow connected to mac and cheese. But we also got this reward because we were basically changing the game and we could really show what transformation means, and we could really show on a very granular level on how it's impacting. Because there's always a challenge, how do I translate a digital tool into value? Today we have 2 plants connected. We're not stopping there. We're bringing this to all of our ketchup plants in Fremont, Muscatine, and Champaign to get all the value on what we have created together doing this great partnership. On the right side, you're going to see how we're interacting with those models. We're going to give you a little bit more details, but we have enabled all our plants today, which have access to all of our data with tablets. So they have access into the digital world. They have access to a digital replica of our management system to do every problem or better understand every problem we have today to improve performance. What people don't see in the background next to having people, process, and technology, we need to manage innovation. How are we doing that? Well, it's also on how you manage innovation with a car. You're building a mock-up. You're building a pilot. Then you decide, I have to scale it. I have to scale it across the globe. The same thing we're doing with digital products as well. We're going to assess the opportunity together. We're trying to understand on a high level what's the feasibility, what's the business case. We discover together where we have to answer the question, that's potentially the tool and the target technology. And we do a technical feasibility check because we as geeks, we love to build stuff. But we also know there are great partners out there who can help us to accelerate their journey. So we're looking at reuse, buy, or build. When our client, who is the function, if it's now manufacturing, supply chain, marketing, or sales, is still happy with the product and is addressing the need, we're building it out. We're letting it play with it. And we're bringing it on where it can add value. And then if our customer is still happy, we scale it and get the full value out of it. Everything what happened with the digital trend today.
All right, so let's talk a little bit about what we did and our approach to building and deploying this digital twin, fundamentally, or a fundamental solution. But before we get there, to just set the stage a little bit of what we're going to talk about, let's talk about how the cream cheese is made, right? So we're going to double click a bit into specifically Philadelphia cream cheese, I think a product that a lot of you probably know. And just to level set, in basic terminology, this is the process and where are we going to drill in and what did we do to optimize. So, it starts with receiving the raw ingredients. Then there's a pretty substantial mixing and separating step where everything is blended and we're trying to, really adhere or get this to the optimal and consistent cream cheese product. Then there's a fair bit of processing and additional mixing. Then we now have the product. We need to fill the packages, and then everything is kind of warehoused and distributed, right? So it's basic, but let's drill into optimization 1 and optimization 2, as you see here on the slide, in terms of the mixing and separating and the filling. And to just give you a bit of scale for what we're talking about, every week we produce enough cream cheese to fill about 2.5 Olympic swimming pools, which a little bit of a weird thought to think about a pool full of cream cheese. But every week, about 2.5 Olympic swimming pools worth of product. So there is a lot of scale behind this, which also means that even micro improvements have macro effect, right? So first is at the point of mixing and separating. What's the challenge here? Well, as it says on the slide, there's a lot of distinct, unique variables and runs and machine set points and configurations, but let's unpack that a little bit. What does that mean? Well, at the end of the day, mixing and separating is not an exact and consistent science. Why is this? Well, there's seasonality behind the scenes, and I don't mean kind of typical supply and demand seasonality. I mean actual raw ingredient seasonality. So throughout the year, milk actually changes, and the fat content and the protein content actually changes, but we need one consistent standard product. So we need to adapt this process constantly because the raw materials are themselves non-consistent. So we're retraining the model as well throughout the year to learn from these historical seasonal patterns and keep us current and make sure that we're, again, not only getting the results we need, but getting that consistent product. We have thousands of data points that we're collecting from sensors on the line, from IoT devices, from various machine parameters, and from other kind of offline settings that our operators on the floor are entering. So all that becomes our data portfolio input set. And then what are we trying to do with this? Well, at the point of this mixing and separating, there's a real opportunity to increase yield. If we can get this right, and again, small changes have big impact. If we can get this right, we can really drive more efficiency in our throughput and our yield. So that's our objective here. And the optimization patterns that are running behind the scenes are determining these optimal machine set points to get to this desired end result. And because of what I said before, that there's some seasonality and there's some inconsistency across the year in how this just organically plays out, every single run of every single day has a different and unique optimization that is run according to basically the status at that point in time and the real-time data at that point in time. You might ask, kind of, why is this? We think about it almost like if you're using Google Maps, right? There is not always one exact way to get from A to B, right? There are multiple different ways you can get there, and depending on when you search, traffic patterns, things like this, right? The optimal way to get from A to B is not always going to be the same. Similar, there's an analogy here in terms of how the cream cheese processing works as well, that the answer is not always the same, and that answer we already know is going to change throughout the year. So we have a portfolio of optimization techniques that are happening here that have resulted in a significant reduction in yield loss and therefore an increase in incremental production and profits. So this is kind of step one, if you think about the cream cheese making process I showed you on the previous slide. And then what happens next? So now we have a product, right? And this is the Philadelphia cream cheese that we want. It's the consistency and the look and feel that we expect. And now we need to fill all the individual packaging. We also have, there's a variety of sizing, there's a variety of pack types, so there's some variability behind the scenes here. But the fill point becomes a real point of failure in terms of potential waste, right? Because if we overfill, which certainly can happen, the more you overfill, the more you're giving away for free to the consumer, and that is inherently profit loss. And you certainly can't underfill either because you have committed to a certain quantity, and you have to at least adhere to that quantity. So you cannot underfill, and you really don't want to overfill, right? The line in which the filling happens has 8 separate, or the conveyor where the filling happens has 8 separate lines, and we're running distinct, unique optimizations at every single line, even in one concurrent run. So there is a lot of parallel optimization taking place, and this is all happening on the shop floor so that these insights can, as quickly as possible, get right back into the line. We've also, I've been talking a lot about cream cheese, but the intent is not that we would only ever do this for that product. So we inherently designed these models in a modular fashion such that they are more easily scalable to other plants and other products, right? Because we want to continue to grow and scale this capability. So in doing all of this, we also, over time, continually optimize our fill rate to minimize waste reduction and yet still keep happy customers. How does this work? Well, all the data on the shop floor is coming in. Our partners ST1 are here. This data streams into, or does not stream, but rather comes into Azure DLS via ST1 and a variety of Spark jobs that are processing this behind the scenes. Then we also stitch together our machine data, which is inherently quite noisy, so there's a ton of data pre-processing that's required. But the machine data comes in as well. Then our machine learning predictions are made. The output of these optimizations are stitched back together with the real-time machine settings. So what are the actual parameters set on the floor right now? How do we take what we should do with what's currently happening and then push down a recommendation back to the shop floor so that this can be carried out? And so this is, at a high level, how this is working, and you can see that a ton of this is built in partnership with Microsoft. But we're not done yet. So if you think about levels of maturity when it comes to digital twin, this is kind of our articulation, right? You have your static kind of level one of, hey, I have like some semblance of what my operations look like on a factory floor. There's no IoT, it's not connected, but I can represent offline what's happening online on the factory floor. Then we start to connect some sensors. We start to make this a little bit more digital, a little bit more data-enabled or analytically enabled. Then, as Oliver was saying, we mature into this kind of intelligent digital twin. This is where primarily we are today, where we have machine learning enablement, simulation models, optimizations happening. We are generating real-time insights and making real-time recommendations. But we need to push toward a fully autonomous future, right? Our desired future state, and we're already marching toward this, is a self-learning and self-optimizing system. Because if everything I told you before is something that we know, in other words, if we know how the machine parameters should be set, and we know what's happening on the factory floor, and we know how to increase our throughput or decrease our wastage, then let's just do it. Let's not wait around for a human being to come in and evaluate and approve. Let's just do it. And so that's the vision of where we're headed. To do this requires us to move from the cloud architecture that I showed you before to operating at the edge, leaning pretty heavily on Azure IoT operations. We're moving everything I showed you before to the edge. That gives us ultra-low latency. It takes us, already our latency is pretty good. Today, we're running at about a 5-minute from data generation online to recommendation in hand, about 5 minutes. We're pushing this down to sub 1 minute now once we move to this edge deployment. It's also a bit more reliable and secure because it's all happening in situ, and it allows us to do more creative cognitive things. So this is where we're headed. And beyond that, this will give us this opportunity to genuinely action against some autonomous decisioning, that stage 4 digital twin of the prior slide. So your data layer, you're sensing, you're collecting data. We're now analyzing and we're running models, but we want to start acting as well. So our decision layer is what we're building, and this is where we get to autonomous. So 2 use cases to show you here. One is bringing unstructured data to operators' fingertips. This is not necessarily a novel thing. You will hear around this conference a lot of discussion around, bringing some natural language ability to interact with unstructured data in a meaningful way. We're doing the same. But in particular, when it comes to shop floor operations, how this used to work, which is why I have a little icon of a filing cabinet here. For decades, there were very thick SOP documents and machine operating manuals that just sat in a filing cabinet or sat on the shelf, and only someone with years of experience on the line actually understood what was happening. The training process was very difficult. Getting the information you needed if something went wrong was very difficult. So we got a little better over time, and we started digitizing things, and we started creating file structures. But we want to bring it to the fingertips through Gen AI, which is what we're doing. 𝗦𝗽𝗲 is Kraft Heinz AI, and this is our internally built generative AI assistant. It started as, frankly, a chatbot, but has expanded to being kind of the front-end experience for everything happening agentically at the company. So our team members at Kraft Heinz know there's one place they can go, and behind the scenes, on the tech side, we handle the routing and the query handling and everything, so that our users have a seamless, intuitive, easy experience, but we're connecting the dots for them. So we are bringing those unstructured data elements to an operator's fingertips so that if something goes wrong on the line, or if I have a question, it's just a simple natural language question away, which substantially speeds up the decisioning. But the second use case is really where we're most excited, which is the genuine autonomous handling. I kind of hinted at this a minute ago, that you don't necessarily need a human in the loop for certain things, right? If you know the right answer and you know that answer applies right now, then just carry out that task right now. And so we're building agents to enact or to act on the recommendations of all of our digital twin optimization portfolio, connected into the actual manufacturing and machine ecosystem to just do it as soon as it needs to be done. This will further, improve our throughput, decrease our wastage, because every single second that we waste matters. When you think about the scale I mentioned and the big swimming pool full of cream cheese, taking action as fast as possible really drives the results. So once we get to this autonomous decisioning point across the digital twin ecosystem, the sky is really the limit in terms of upside. So this is where we are in the journey right now and what we're excited about. And to kind of bring it home and show you a bit more about what we're doing today, I'll give it back to Oliver.
So we're really proud of the stories we're sharing with you today. We're really proud of all the results we're sharing with you. But we would like to take you on the shop floor itself. We would like to show you everything which has been presented today is not science fiction, it's science fact. So we prepared a short video from the shop floor for you.
Our journey began with hands-on work. Every day, our teams were in the heart of the action, performing manual tasks, recording data by hand, and ensuring that our machines ran smoothly. Our shop floor thrived on routine, with the Kraft Heinz management system as the backbone of our operational excellence. But excellence isn't static, it evolves. We knew there was a better way to drive efficiency, safety, agility, and quality. Enter digital transformation. With tools like Connected Worker, our teams now operate with real-time insights at their fingertips, reducing downtime and increasing precision. With end-to-end process control and digital twins, we've redefined how we manage our operations. From predictive maintenance to performance optimization, these tools have turned data into action, allowing us to anticipate and resolve issues before they impact production. But digital transformation is about more than technology. It's about people. We've invested in training our teams, ensuring they have the skills to harness these tools and take manufacturing to the next level. By empowering our people, we're setting the foundation for the future of production and supply chain management.
It's been a journey. It's been a long journey. We had a lot of lessons learned, but we're always standing up, keep on improving. I think one of the proudest moments here at Kraft Heinz is that all those small incubators, which we started the last 3 to 4 years, we scaled them. And this is where really comes the value. Sometimes it's really hard to get the value out of digital because it's still digital. Sometimes it's just a dashboard. Sometimes it's just the numbers. Sometimes it is just something. But connecting really your digital tools with value really starts to kick in when you scale and you're receiving this feedback. So you could see also in this video, it's process. You saw the Kraft Heinz management system. You saw people on how you have to enable the people, on how you have to pay attention to them. And we should never forget on who we're doing this for. And you saw the technology. So when you bring those 3 things together, it will be a great journey. Also along the journey, what you should consider is for every dollar you invest in technology, you should invest $2 in the change management process itself, because there is now a lot of technology available on the market. And it keeps on re-innovating every 2 to 3 months and even faster. Technology is available. Driving a real transformation, that's the hard part. Even if you bring the best tool to the shop floor, there will be potential reasons why people will not accept it or will not work with it, even if it would address the problem. So what we shared with you today is when we break down the digital twin, we're having now set point intelligence to eliminate overfill and underfill. We shared with you in order to make this use case work, we're bringing our intelligence from the cloud down to the shop floor, down to the line where the magic happens. And we're using Kai as an expert to help our operators to solve really tricky problems and improve line performance. What's next for us? Knowledge retention. When you make ketchup, it sounds so simple, but it requires a lot of knowledge. When you look at the color of ketchup, it requires really tight specs in order to meet this color. The flavor, the texture, all those kind of things require expert knowledge. And we have been on this journey for years in every industry. How can we retain knowledge? On the other side, sometimes when we talk about digital twin, we talk about the 3D replica of our plant. But for us, the digital twin addresses a really specific problem. It's the process digital twin. It was a bigger business case than representing our plants in 3D, which we can, which helps us in engineering, but it's always a business case choice. What we would like to share with you before we wrap up this session is that we're not stopping there, and we would like to show you on how the cookbook is helping us on cognitive offloading. With the cookbook, we're trying to digitize 42 years of ketchup knowledge. If you attended my previous session, I was talking about our beloved ketchup masters. Those guys hold the knowledge over more than 42 years on how to process and package ketchup. Those guys are called 30 times per day. So what happens when they actually retire? And it happened. So from a change perspective, the sense of urgency was already there. We had to do something. We had no choice. And this is where Microsoft helped us, together with Copilot, to digitize this knowledge, to basically take the brain of our ketchup master and digitize it. But where do I start? What we did is we're connecting our structured data, the data world, which comes from the machines, with unstructured data, which is the knowledge of our ketchup masters. What are the top 100 tricky problems they have to solve every day? What are the people asking, calling them every day? And you cannot solve this in, you have a project, and after 6 weeks, or 3 months, all this knowledge is digitized. It's a product. It never stops. This, with Copilot, it continuously learns and keeps on going. We could just make this happen with great partnerships and great people. What you see here is the ISE team from Microsoft. What is important to be successful on this digital journey is domain expertise, because you need someone to explain to you the problem on a very granular basis. You need to understand where to look at, which data to get, and how does it work, which KPIs are impacted. Of course, you need data. So we found a partner who could help us on the data piece and give us the right data at point. As Pat presented, every asset has its unique use case. This basically means looking at specific data you need to grab. And if you go fast, go far, and together, you know the drill, but this is basically what it is. We work together with Microsoft. Also, internally in your organization, you need to work together with IT, technology, procurement, all the functions which are there, the people from the shop floor. You all need to work together to make it work. Because if you want to go alone and just show the tool, you're going to have challenges. This partnership brought us on where we are, bringing at the next frontier of innovation. Thank you.